Hey, welcome to today's live stream on Live Code Tuesdays. My name is Sohan. I'm streaming from an unusually sunny Amsterdam today. And today we're going to be talking about security and .NET with Niels.
Yeah.
Niels, also based not too far from where I live,
No,
close
and
to
it's
Amsterdam at least.
definitely sunny today. We were talking about it just before we started, right? It's a nice day to go outside a bit, and it's good that it's changing, right? It's not any more rain that we had over the last couple of months.
Yeah, yeah. Thankfully. All right. So this is Neil's first time on Live Code Tuesdays, but he's done so many talks on things like security and WebAssembly. In fact, Fermion met him at VR Developers in Berlin, I think, last year. And I
Yep.
think that's where we got to know each other. So Niels is a senior principal security engineer. Niels, can you tell us a bit about your background in
Yeah.
security?
So I mostly do security research in the static analysis space, and I have a background in .NET development, which I've done like since the early releases of .NET. Always intrigued with application security in general. And right now, I'm mostly focused on like, hey, if you do static analysis on .NET, like, what do we want to show to our customers in that case? And what also caught my interest is the fact that I'm doing a lot of public speaking on this type of technology choices and secure software development, supply chain stuff, and also WebAssembly, because I think WebAssembly is a pretty cool stack. And putting my security hat on, looked into it, like how some of its internals works, and that's exactly how I created that talk that you saw. We are developers. I've done a series of it, and it evolves because, as you all know, WASM and all stuff is pretty moving like in a
Yeah,
fast pace, right? And that's something stuff that I enjoy. I love to do public speaking, Microsoft MVP as well in that area. So
nice.
that's the thing I enjoy, and I can combine it and still write a lot of software and have fun with technology. And I think WebAssembly is really up for it, especially in combination with .NET. So that's the
Nice.
reason why I'm here.
Yeah, and that's what we're going to be talking about today. Let us know where you're logging in from and who's in the audience. I see Vamshi here. Hey, Vamshi. Vamshi is based in Hyderabad, India, I think. We spoke yesterday on the Spin community meeting. He also has contributed to Spin, and if you all have things like internships or jobs, he's your person. So, do reach out to Vamshi or let me know at least, and, I can put you all in touch. The active Spin contributor. Niels, why don't we get to it? Let's
Yeah,
talk
we get to
about
it. I got a couple of
security. Yeah.
slides and hopefully
Okay.
a lot of code that we can go through and then
Yes.
see how it works. Because I usually start out my talk explaining about the evolving like of WebAssembly, how I started out. I'm not going to bother the people that use this,
Yeah.
like, what's this
Our
thing?
crowd
And
knows
that
stuff about WebAssembly. Yeah.
exactly right. But I think if you look at the design, the thing that caught my eye instantly when I saw is that WebAssembly, one of the points is related to the fact that it wanted to keep it secure because everything runs in an executed like sandbox mode, right? And I've been doing a lot of sandboxing in .NET context as well. And I think looking at the stuff that was written for WebAssembly, that makes it really a really nice thing. And aside from that, also it's quite similar because it hopefully it's the right ones run everywhere type of ideology, right? Which is good. I get that. But if you look at it also from security perspective, one of the goals is to protect users from buggy or malicious modules, right? If we see some of the talks that were done, I think Lynn Clark does a couple of them, and some of the others of the Bytecode Alliance talking about a malicious module. I use those slides with the module that has a rogue cap on, right? That will
Yeah.
turn malicious at some point.
Looks malicious. Yeah.
Yeah, it looks malicious. And wants to do some stuff that it's not allowed to do, right? We should maybe contain that and have less of an impact. And that definitely is something like least privilege. If you put your security hat on, that's definitely something that's nice. And on top of that, also I like useful primitives in a way that the default, if you run WASM time, right? If you have a module by default, nothing works, right? And you need to grant it access to stuff, and that's exactly the thing that that caught my eye. I thought, okay, this is pretty cool. And if you then look at what makes WebAssembly as a as a technology stack, what makes it secure, of course, the way that it deals with memory, right? So everybody probably knows like each module will have its own piece of memory that that module can only use, and it needs to have some help in case of, let's say, a component model, right? It needs to get some help to get access to other stuff. But the nice thing is that it will just have a set of like it can only access this, and I think that's quite powerful. The only thing that then could something that we should worry about is maybe like what happens if a module contains a vulnerability or has the ability to mingle with its own memory, right? You can still have some unintended behavior, and that might still cause problems, or that might still cause like security issues for that matter. So in order to have a good layered security approach, we need to have an additional thing. And another thing that WebAssembly also relies on is a concept called control flow integrity. And I was looking to like, how can I explain this easily? And then, of course, being a C# developer myself, just take a piece of code and then try to explain what's happening here, right? So if you look at this logical block that we see on the slide, it's pretty straightforward, right? There's like something is being read from the input. We have now a console write that will put it out. Then we have a condition check. And then if it's like larger, then it will say, hey, this number is larger than 5. And otherwise, it will say smaller than 5. And then it's done. But if we look at this code, we can create a map out of it, right? We can chop it up in separate pieces. And we can say we are mostly certain about the fact that it will execute in the following way. We can say, okay, we know the first block will always execute. And then we have a condition check that will check the number size. And it will say, oh, the number value, and it will say it's 5 or less. And then you have 2 separate parts. And then at the end, it comes together. And this is something what they call control flow integrity, right? It's just a map of possible execution paths throughout the application that will be created at compilation. That will be done by full WebAssembly modules once you create those. So that's powerful. And if something happens that is unexpected, then it will turn into like a trap, right? It will stop executing. And of course, there's always the exception to the rule. I think EFF has a real nice paper on control flow integrity in general, and what of course are the caveats. There's always a downside, but it definitely minimizes the risks, right? And I think that's the key thing. If you're developing secure software, you want to mitigate or minimize risks, and something might be acceptable, because if you want to secure stuff, like you just need to or turn it off or just dig a hole and put it in and don't touch it, right? But that's not how it works.
If I had to, sorry, Niels, but I have a question here. But
Sure.
If I had to compare and contrast it with a language, a programming language that doesn't necessarily have control flow integrity, what would that look like, right? And what are the like pros and cons there?
So if you if somebody is able to influence the way the application executes, right? And that's like a return object, like a return-based programming where people can influence the chain of stuff that executes. Then a person can maybe say, hey, I don't want to do this condition check. I want you to go to a process start, and I want you to spin up this executable for me, right? Then you will divert from the default route. And I think that for .NET, there's no safe guarantee that it will do it once you compile it into the .NET assembly, right? That's a different story. So return-oriented programming, that's the thing, Rob, that's the thing I was searching for. And if you look at exploits, especially in case of, let's say, unmanaged languages like C, C++, the gadget you create, which is like the thing that executes, that will do the stuff that you want it to do, will have different instructions than the one that it was compiled with, right? And for that matter, it will stop executing if you have control flow integrity enabled. And I think that's the biggest difference, having a map of the possible steps that will come next, and then eliminate that, and that will safeguard those kinds of risks if you're in unmanaged languages, for example, right? So that's the thing. So having memory per module, having control flow integrity, that stacks up pretty nicely, and that gives us a lot of secure stuff by default. And the nice thing, which is also a nice bridge to unmanaged languages, is that there's a project that's been created by the people behind Firefox, Mozilla Firefox, and it's called RLBox. And what they've done is they've taken some of their unmanaged plugins, which is like C, C++, and from the early days when we start using browsers, if somebody could hack a plugin that renders a font or a video, you might have got process execution, right? You might have got stuff happening inside the browser, and you can take over somebody's machine for that matter, right? Aside from maybe what we see right now, browsers are really good at sandboxing and process isolation itself as well. But in the early days, it was worse. So what they decided to do is that, aside from the fact that they create a program model that will allow you to use a plugin safely, they also take the existing C code base and take scripting and compile it into a WebAssembly module, which of course gives them all the guarantees that I just explained, right? You have the module per memory per module constraint, and you will have control flow integrity on top of that. giving it pretty much eliminating all various style of problems that they probably can run into. And what they then did is that they took the WASM file and compiled it back into C code, because they still want to have like a single code base with not like stuff combined. And that's what they do with this RL box. So they leverage the fact that WebAssembly has those security primitives I talked about with memory and control flow integrity, and they utilize it to use it inside of their browser. And I think that also illustrates that security is, for WebAssembly, is pretty good, like done in a good way. There's always constraints. I'm going to get there once we're going to talk through, but there's definitely, the baseline is good, right? And that's really cool. Security-wise, now because I'm a .NET guy, I'm going to talk a bit about like how .NET runs on top of WebAssembly, and most of you probably are aware of it. But if you would cut down an application, and this is an image I stole from one of your colleagues, Sean. I even created this one in his presentation, and I saw this whole scheme. I thought, this is exactly what I want to tell, so I just copied that. I think it was a WASMCon presentation or one of the others that he did. But you have IO code, like the user code that you write, first-party code that you develop yourself, that you then run, that will utilize a base class library. So in .NET's case, that will be all system.io file, all system stuff you need, process diagnostics, console, all of it, right? That will run on the execution engine, which is called a VES. And in .NET world, that will be a CLR, the .NET CLR, right? The runtime that does it all. How can you get .NET running on WebAssembly? You replace the execution engine or the CLR with one that runs on WebAssembly. And that's exactly what Steve Sanderson of Microsoft did with Blazor, right?
Yeah.
It takes the .NET CLR, puts it into a WebAssembly space, and then you just run your first-party code inside the browser, and it's just .NET assemblies. If you run that app, you will see, we'll download .NET DLLs, right? It won't be WebAssembly modules, but it will download it. So that's pretty cool. That worked. That was the first thing, right? But this is, of course, constrained to the fact that you run inside a browser. And this is the default, the template that you use. But the thing that makes it more powerful, if you can take that whole concept outside the browser and leverage all the sandboxing and security stuff, right? And that's exactly what I was interested in. So taking away the part of the browser, we need something else that replaces, right? And that's, of course, exactly what WASI was meant for doing, taking stuff out of the browser and having WebAssembly run on literally everywhere, which also means that you might have got devices that have got constraints, right? If it's an IoT stuff or something else. But that will also allow you to run .NET on it. And I think this is definitely the thing that caught my eye. And then once I thought, like, this is going to happen, how can we work our way through with .NET and make it workable and make it something that you can use, right? So Steve Sanderson, that's mostly like a person who does a lot of net scientist work. That's mostly also how I look at him, like from the .NET space. And he also created an SDK that allows you to do .NET development based on WASI. And this is exactly the demo we're going to work through a bit. And I'm going to show you how it works and how that relates to running .NET on top of WebAssembly. Right. So if you could switch to the VS Code.
Niels, yes, I'll switch. No, also we have a question from Kay asking if this is live. Kay, yes, this is live. Hi, Kay. Thanks for joining. Yes.
It's a quarter past.
Yes. No, but there is a good question, which is, sorry if I joined late. How does .NET handle garbage collection in WASM? Do they bundle the garbage collector? Is that something you're getting to in a bit, Niels?
No, I'm not touching it, and I'm not sure if I know all the internal details of it. But right now, it keep in mind that the CLR and the stuff it does, it interprets the .NET DLLs inside the browser, so it will have its own garbage collector still available and running inside the browser on WebAssembly. I believe there are certain initiatives where they want to see if they can move to the GC within the browser, because that will be more efficient, right? I'm not sure if that, I don't know like what the plans on that are, but right now be aware that it's an interpreted version of .NET that runs inside the browser that will leverage WASI, right? So in the garbage collector is just part of that system. So it's not leveraging anything that's in the WASI ecosystem for that.
Okay. Yeah. Hope that answered your question, Kay. And yeah, let us know where you're watching from. I'm not sure if you have stopped by a stream before, but we stream every Tuesdays about the WebAssembly world. So yeah, feel free to drop by anytime. Niels, you were saying.
Yeah, I'm sorry. Maybe I'm just going on like a quick pace. It's like almost a rant on doing this. I should maybe pay a bit more attention. So this is if you with .NET 8, the Microsoft team has released an experimental WASI template you can just download and include into your developer workspace. And you can say .NET New Console, WASM console, that's the name I believe, but it's a distinctive one, and it will create a default project, which if people are doing .NET development, you probably recognize that it's a project file. It will have a runtime. It will run WASM, and it will do some other stuff underneath the hood. And we can just compile a normal console app, right? This is the normal hello world, but right now we're going to do hello from, and we're going to look into the architecture that we're running on, right? Because I think that's one of the key things. So if I now do a .NET build, what will happen underneath the hood, which is like the normal building you would do for your .NET application, it will create the app itself, but it will include a lot more. And as I said before, it's doing a lot of more things. Hold on, there's an app bundle directory that I want to go into. So what we see here is I have created my my console application, and I've got a .NET WASM file, which is my .NET runtime that runs on my machine right now that will take care of it. And there should be a DLL in this one as well. Let me just make sure that we're on the right thing and just do a .NET build.
Yeah.
Sure
Bunny is here. Okay. So Bunny is one of our regular viewers. Bunny, I was actually panicking for a bit, saying, "Oh, Bunny's not here this week," you know. But
did somebody
I'm so
check
happy.
on him?
Yeah, I'm so happy you're here. But also, I think Bunny sort of reiterates what you said, Niels, which is, yeah, most other garbage collected languages generally bundle the GC into the WASM binary itself. So pretty much what I think you said, right? Yeah. Awesome.
It's almost equivalent of doing ahead of time, right? It's you can probably do a lot of ahead of time with the .NET stuff, which I've also seen in demos, but it doesn't pay off for the whole like thing, because if you do ahead of time with .NET, it might explode in size, right? That's stuff that you don't want. But if there is performance stuff and you do some stuff that is closely to some hardware, then it might make sense, right? So there's always that trade-off, and I think as far as I'm aware, I don't think it's not going to happen. But they probably will look into maybe some more optimum GC if you're running it inside of the WebAssembly runtime by leveraging the standards that are there instead of relying on their own. So that's cool. Let me see if what we have here. If I may, hold on one second. I'm just going to open up once more. And if I do a .NET run, I should be fine. So what it does right now, because I do the default template, you will see that it will run my application. And what it will do is it will take WASM time and run the .NET CLR, and it will pass on the console app WASI DLL that I created, which is my .NET code that runs on the CLR, which is the .NET WASM, right? So right now we see over here, hey, this is hello Fermion from WASM. I can still force it to do a thing that's tied to my hardware on my machine. It will give two errors, but I will show you that it also creates a binary that's just native to my machine, which will probably tell us that it's an ARM64 machine that we're running on, right? Which is my Mac in this case. So this is the same code, but the thing underneath the hood is different. The architecture that it runs on, right? In this case, WASM time versus my native, my hardware, my own machine.
Yeah.
So what happens if we open up files, and probably everybody knows what's happening here, right? It's if I say, hey, give me a read all text, give me the file that's on my system, and then I want to give it access to this, then everybody probably is aware of like, hey, and then console, let me write out the content to the thing that we can see. If we now build this, should have saved it. If I now say .NET run, it will still do the WASM thing. I think it didn't save it. So hold on, save it. Yes, now doing it again. You will see it fails, right? Because it has no access to my system. So WASM time limits the fact that, hey, if you don't have that directory pre-opened or mounted in some way, you're not allowed to access it, right? So in order to get access to it, I need to make sure that I'm doing the directory opening for that matter, right? So let me go to the WASI directory I was in just before the app bundle one. And there we have a run. I think we can do the same here. So now I can say, okay, let's also give it access to etc folder on my system.
Mm-hmm.
Then we will see it will have the ability to do that, right? It will because it's pre-opened by the runtime. It gives us the limitation. And the thing that I miss out the most with .NET is the ability to limit libraries of what they're allowed to do or not, right? And in the early days, we had a concept called code access security, which had same characteristics. You need to you can limit somebody's access to certain areas, like even was files. And unfortunately, it was not that safe because you can turn it off in a pretty easy way.
Yeah.
But the concept was the same. And the thing that I also not like, I think it might have not have worked out that way is, if you look at WASM itself, it's a standard that's like being built right now by people using it. And code access security was just being dropped by, hey, this is a thing you can use. And then it turned out not to be as practical and also really hard to do right, which is also a problem with security features. If it's hard to do right, then people will make mistakes and there will be security issues, right? So this gives us the ability to give more control. And if I now do the same thing again let me just quickly open up once more. If I now do the .NET run again for the DLL that we saw before, so bin debug, and then we're going to go to my native one, console at DLL. You will see this one. I haven't saved this. The file probably didn't close it, did I? Hold on a second.
Yeah.
I didn't build it explicitly for the other architecture. Hold on.
Okay.
I built you.
Yeah, Barney's saying that, okay, even in tiny Go, you pass a flag to omit the garbage collector, then do a bunch of defer delete to manually tidy up at end of scope. Interesting. Okay, I didn't know that. Yeah, so it probably works similarly where the GC is bundled into the WASM binary for .NET as well.
Yeah. This is doing the native binary, right? And that shows that it has access by default, right? So this is the thing that caught my eye when it started out. This is all preview 1 bit still, of course. It's not preview 2. Has been released lately, but I think with the stuff that I've seen from Spin, if you have components and you limit, you do exactly the same, right? You predefine stuff that it's allowed to do, and you can even do stuff with hosts, which I think that's definitely powerful stuff. So getting our way through, this is running .NET on WebAssembly, and when I was doing all these demos, I thought it would be even nicer if I can do some composite applications, right? Which is in some way component model, but just take the WASM time runtime and use it inside of a .NET application to run a module that's written in another language, right? To do some polyglot things. So the other demo I'm going to show today is more related to extending .NET application with another stack, and in our case, it's a Rust module. So let me open up this code base a bit.
Yeah. For those of y'all who just joined in, my name is Sohan. We stream every Tuesday, and we call this Live Code Tuesdays. And today we have Niels. Niels is a senior principal security engineer, and we're talking specifically about security and .NET. So Niels just showed a demo of how he specifically gave access to a particular folder, and only then we were able to access it because of WASM Sandbox. And now he's doing another demo where there's a .NET module and a Rust module, correct?
Yeah, and the .NET module will execute the Rust module. So it's like a poor man's component model. I think this is probably how you can capture it. Because I think this shows the power of having the ability to write something in a different language and just use it, right? The demos that you see others do as well is like taking a markdown parser that was written in Rust, compile it into WebAssembly, and then use it inside of the .NET application. So all the demos I'm doing right now, there's a GitHub repo that has the name of the stream that I'm going to share at the end. I also have a demo where I do the same with Python and all the demos previously, right? So it's because to show that it is able to do it on every technology stack that you can imagine, as long as it's able to compile itself to a WASI compliant thing, then you can use it, right? So what I'm doing right here is WASM time, and Peter Yoon always releases the version, I believe, they create a NuGet package that allows you to run WASM time inside of your .NET application. And putting my security hat on again, I was mostly looking into how can I sandbox third-party libraries, and I think like, hey, why can I not like run .NET and then run .NET on WebAssembly inside of .NET, which of course is a lot of layers. I'm not saying that people should do it, but it's more like getting my head around like, would it be a good model to have that sandbox that I'm missing out on right now within the .NET ecosystem. So this is just the default Rust. I think this is even the default Rust demo you find,
Nice.
where it takes a file that can copies it from A to B, right? It's always the file operations that you saw with preview one. But we're going to do a bit more in this one as well. That will just show that it works. Just a default console app, right? That's how it is, and it processes files and it will copy it from A to B. So this one gets compiled into a WASM module that I then use, and I have some scripts that will copy it, and it will be part of this project. As I said before, it's just a matter of taking the WASM time. Right now, this is version 17. I think this aligns with the WASM time version itself. So I'm not sure if this is the latest, but this one right now, this combination works. You need to do some more stuff. There's a lot of more ceremony, right? And I'm not sure, like this is something you do not want to do if you're doing production code, but I'll get to that in a bit. But it will illustrate the power as well. So it will just create a WASM runtime. What you see over here, it will create an engine, a linker, a store. We'll set some configuration. It will set some other variables that we're going to touch in a bit. Then it will load the module, and then it will execute the main of that module, right? So no fancy interface types yet, but it will just take that and it will invoke it, right? So if I then make sure, let me open up a new one to be in the right folder. If I then go to the console and then just do my ordinary .NET build, if I now say .NET run, you will see that it will give us an hello from a certain coordinates. If you're having fun, if you look up those coordinates, you probably will get to a point where I'm at right now or close by. But it will just do, this is the module, the Rust module that's giving us back this information. And if we briefly look into what I'm doing here, hold on a second. I'm just tying the standard error and the standard output to the console itself, right, in order to have it visible. And I will also pass on all the args that are given to the host, right? So the bootstrapper host will do all the heavy lifting of creating the module and instantiating it, and then we can use it. So if I now do a .NET run and I want to do the copy again, right? So this is the executable. If I now want to copy the hosts file again to my local current folder, you will get a much nicer error than the one we saw before, saying like, hey, it's not pre-opened, right? You cannot access it. And in order to grant it access, you need to instrument the code to do so. And that's, of course, what we need to do. So we can tell, I think it's with pre-opened directory, you can say, and I'm hoping I typed this right, because for some reason my intelligence is failing right now. I'm not sure what's happening here.
That's okay.
But I can mount. I'm sorry. Please.
Oh, no, go ahead.
If it fails, then we're going to see it straight away.
Yeah.
It is, right? Pre-open directory, it's a different name. Hold on, let me see if I can restart this one.
Yeah, and folks, if you have any questions about security.NET, WebAssembly, here's your chance. Again, just to reiterate, we are doing a demo with Niels here, who's a senior principal and security engineer, and he's showing us about security and .NET. And right now, we're doing a demo where there's a .NET was a module that's talking to a Rust module. So.
And now there was a capital, right? It's for some reason my LSP failed, right? And it's always the demo gods, and I've demoed my way out of this a lot. So if I now do a .NET run and say etc hosts a host file, and I want to copy it to my host current directory, then it will say, hey, it cannot find etc host. What did I do wrong? Because I think I might have just did one of the directories. I need to do both of them. With pre-open directory, yes. And in order to write to my own folder, that's what I mentioned about having secure defaults. And that's also what you saw with the early demo. If you do WASM time, you also need to give granted access to its own folder in order to write files to it, right?
Yeah.
That's not how it, that's not the default. As I said, I enjoy that. So now let's do it once more. This one fails. I got another one ready that will show us right outcome. .NET run. Let's see. Host. And now it has copied the folder to my system directory that I'm in right now, right? So this copies the file because I granted access to it. So this is like exactly the same as you saw before. It's not fancy, but as I said, I like the fact that you can control the stuff, and it's not that it will be exclusively enough. It's a layered approach, right? People always say like, hey, but if I do a container that has like limited access, yes, that's always a good thing. But being able to express yourself, even with the component model stuff that I'm touching in a bit, it gives you the ability to have multiple layers. That's what you want in security, right? No single fail layer, but several to fall through and to do the right thing. So this is nice. And I
Niels, we have a
already
question before
sure.
we move, which is a question from K again, which is WASM support the same across all .NET languages? Like if I pick F#, am I missing out on anything as compared to C#, for example?
I think with F# you can just consume NuGet, right? And I think it's probably the same. Should be good. I don't think there's anything you would miss out on.
Okay. I mean, I don't know because I'm pretty clueless on the .NET world itself, but I can tell you that we at Fermion, we're actually working fairly closely with the .NET team for the release of .NET 9 so that it has better WebAssembly support. So there has been a reasonable amount of interest, I think, in WebAssembly and .NET. So yeah, we're actually working with them. I can't give too many other details, of course, right now, but hopefully you'll soon hear a lot more.
You made me really curious as well. This is cool stuff. Yeah, I spoke to the team that initially did the template work for this, and they said like, yeah, with .NET 8, we plan to have a preview of the template available. That was the first step. So like, okay, that means that WASI will be available for .NET developers. He said, like, yes, I said, okay, that's cool, right? But I'm really happy that you mentioned it. That's nice. But I think from getting back F#, if you can just consume a NuGet package, you will be fine. I don't think there's any limitations on how this is going to work.
Yeah, that was breaking news. Yes, you heard it here first.
So the other thing that I think with preview 1 you could also do with WASM time is doing stuff with fuel consumption, right? With having certain amount of fuel to execute compute, right? And I believe there's no direct relation between like each operation will take one fuel, but it's just a concept. So you could say, I want to limit the amount of fuel. You can also limit the amount of memory that a module can consume, right? That's the other thing. And if I then say, okay, let's just execute this and give it enough fuel, because running .NET on top of WebAssembly, you can imagine it's not that like efficient. It's not, it will consume more than if you have something that really is like ahead of time running on WebAssembly itself. But we can probably get away with this. So what I'm doing right now is I'm just saying, hey, limit or just register the amount of fuel that gets registered, and I'm just putting in 50,000, which should be sufficient for the stuff that we're doing over here right now. Let me just get rid of the file for now. And if we now do a save again, run again, it will take a bit more time. And then we see that it has consumed 14,000 units of fuel, almost 14,500. And we could, of course, say like, hey, if we run an app, then we want to make sure that we know that it's probably needs to be done in X amount of fuel. And if it then exceeds that amount of fuel or exceeds that amount of memory, it might be a good idea to cut it off, right? And that's exactly what I'm going to do right now. It's not a fancy demo, but just say like, hey, if I now take this, and you already saw that it had like 500, which is of course much too short to get this all done, we will see that this will, of course, run into a trap, because it stopped executing and it consumed up all the fuel within the WASM runtime that was run inside my .NET piece, right? But it gives you more control over what it's allowed to do, and I think that's quite powerful. And I was really happy, and then even seeing all the preview 2 stuff landing makes it even better. So I think right now, if there are no more questions, I would like to move back to the slides and continue from there.
Yeah. If there are any other questions, feel free to put it in the chat, folks. Would love to take questions, but yeah, we can head back to the slides. Yeah, there we go.
Cool. Let me see where we're at right now, what the next slide would be. Right, so this is the experimental workload that I'm using, which is part of .NET 8 release, and then we need to keep an eye out for .NET 9. That's cool, so on. So we've extended that. That's the demo. A brief touch on trusted computing, because there's also some other stuff that I saw happening. There's a project called Anarchs, and Anarchs allows you to run stuff on trusted computing level, which is a certain area of your CPU, and that makes it really cool. Because if you look at it from a cloud perspective and then a risk model perspective, this is the XKCD drawing that they made that will explain to you, like, these are the risks that you need to face. And at some level, you might have got like an employee that gone rogue, or a nation state if you go lower into the level, but these are different risks.
Can you believe it, Niels, that we've been doing the stream for a fairly long time. This is the first time we've had an XKCD comic on
Seriously,
stream, which it shouldn't be the case. I think we should have.
I literally use them like in each of my talks. I guess I have the other one with a stack of bricks as well, which is like the dependency thing with supply chain. That's the other thing I'm talking about. Okay. Right? Or Jimmy drop tables with SQL.
We have referenced Jimmy drop tables though. We have it.
That's the historical one that everybody knows, right? But I like this one, and this is one that came from the Anarchs documentation. The project itself is open source, is still there. I think there's also a Linux Foundation group that focuses on this, so this is cool. But I'm not going to spend too much time on this. But internally, it does a lot of things related to eliminating all those middle layers, because it relies on WASM to run, right? So it will allow you to run an application that's WASM based into that section of that CPU that's safeguarded. And there are some heuristics happening that it will check its startup time to see if there's some mingling done or not. And I think their WASM runtime itself is WASM time as well, that they use internally close to what they're executing. But there's some real cool stuff happening. And I think this also shows the power of WebAssembly being able to take any Go, Python, or whatever that's WASM compliant and run it on that level where you need to have confidential computing. If there's data involved, that you want to that you would not like to drop on the cloud provider by default, right? You want to have a different risk model. I think that's the thing. So this is quite cool. And then last year build, Microsoft also showed Hyperlight, which is their take on this. They will take, I think, a hypervisor as well, and then run WebAssembly on top of a hypervisor. And why do you want to do that? This is almost like my .NET isolation story. So on the left-hand side, you see a screenshot of Steve Sanderson showing running .NET inside of a WebAssembly runtime inside of .NET. And why do you want that? Because you can isolate it. And the demo that he showed had some nice code flow that allows people to have a single line of or a single file of code, and then have an action, which is like a function delegate, being passed on to the other runtime to execute, right, as a sandbox. And I think this is pretty cool. And at WASMCon last time, there was one of the developers from Hyperlight explaining why a hypervisor can add an additional layer of security. I think that's the best take on it, right? They showed some memory corruption bugs that they found in WASM time, I believe, and the hypervisor took care of it because it's pretty good at isolating. So that makes it nice, right? And especially having those different cloud workflows, right? With Fermion Cloud, with web modules or containers, depending on what you want to achieve. I think this is definitely the way forward on dealing with that. And of course, that made me happy to like last January, of course, like when Preview 2 was released. Yeah. And the thing that I'm mostly keen on getting right now is getting stuff running. So WASM Vert is a project I run into that allows you to create existing modules, but also have a file system replacement for a WASM import that needs to be fulfilled. So if you're running on hardware, that's the example that they use, that has no file system, you can create a virtual one and put it on top of it, right? Which I think Fermion Cloud almost does similar things, right? You tie something to a file system, and that might be a list of static files that will be embedded, or it might be a pre-opened or mounted directory that's available somewhere. With WASM Vert, you can do the same. And technically, I was seeing like, hey, you can take a module and isolate it and say, hey, it gets its own file system, or it might only be allowed to access these hosts that I would love to like limit it to, right? I think that's the other thing that I'm mostly interested in seeing, having more granular control over what a module is allowed to do or not. And don't have to worry about if stuff changes in the future, because it's not allowed to do it, right? If a module has a vulnerability or if there is a problem. So WASM Vert can help out with that, right? I think this converts it and wraps it, allows you to run it on Preview 2. And I'm still stuck in Preview 1 bits because that's what's working right now for me. But I think with Fermi and Crowd, you're doing Preview 2 already with stuff, right? So this is the thing that happens. But I was
Question
talking
for you,
to.
Niels.
I'm sorry. Yeah.
Yeah. No worry. Like I think from your vantage point, right? And it's a very broad question, but how do you see, like WebAssembly change security at like say the enterprise level, right? Because clearly, like with the XKCD comic you showed, there are all of these different vectors of attack when you
Yeah.
typically look at like a tech stack, right? And
Yeah.
do you see some sort of change eventually down the future with an adoption of this, perhaps?
I think because we can get much more finer grains, much more smaller workloads, we can also put that on that trusted like layer, as I just mentioned with the project like Enox or with Hyperlight or whatever, right? That helps. You can also put it closer to the data, where the data is located, and have it like shortly accessing stuff if it's sensitive. So I think that's quite powerful, right? Being able to write once, run everywhere, and that's
Yeah.
also for all the security features you get for free. And I think if you look at it overall, and let me briefly just touch this WASM component SDK,
Yes.
because I think this might be this is the SDK that I would love to see implemented for .NET, and I think some of the people are working on it right now, where you can just do all the weird stuff within .NET space, right? And all the heavy lifting will be done on generation, probably Roslyn generators that will generate the code stubs for you, that you can just use it. And this is cool. This is stuff I would love to see. And then I'm curious how security, hopefully declaratively, is going to land on top of that. But the overall thing is still as secure as its runtime, right? And this is I think this is the right segue, and this is the thing that we definitely need to touch. If you look at the whole security space and all the offensive work that's done on this, mostly focus on VMs, like the virtual machines that run WASM, and then focus on what we see over there. I think it was 2 years ago on Black Hat, there were 2 talks about fuzzing, and they found stuff, which is of course a good thing because that will improve the runtime, right? Because the whole thing is still as secure as its runtime. Yeah. That's also the reason why the hypervisor combination might be a good one. But the thing that I like the most about WASM time with Bytecode Alliance is that there's really much thought being put in how to make it secure, and also all the transparency around it. That helps a lot, right? If you look at Anarchs, the fact that it's all open source, everybody can look at it, that makes it quite powerful as well. There's no closed thing happening. You can just look into how stuff works. And that's from security researcher perspective also, I think, a big plus. Instead of having something that's closed, we cannot access it because nobody knows it, right? That's just a matter of time before people were able to figure out how stuff works. But getting back to WASM time, as I said, it's written in Rust, right? So control from the integrity is part of that as well. And all the fuzzing, formal verification, and the whole process around it, that's all well taken care of. And there is a really nice talk done at WASMCon last year, September, right? By Nick Fitzgerald, who talks about what they do for WASM time and how they focus on fuzzing and how they focus on disclosure stuff and feeding back, having a feedback loop on getting stuff fixed, right? So I think from that perspective, because it's a write runs run everywhere, and also an eye on the runtimes, right? It can be a good combination to have in a layered approach, right? So you cannot say, hey, if I do stuff in WebAssembly, I'm good. No, for sure not. But as I said, you want to have additional layers of defense, and I think this is definitely a good step forward from that perspective.
Yeah, for sure. With the launch of WASI Preview 2, which happened, I think, end of Jan, so about a month ago, and now the support for things like streaming and also rewriting of some of the earlier standards and APIs. Anything that you're looking forward to at least implementing, trying out, that sort of thing?
Mostly how stuff would fit into a developer workflow on using all the capabilities of limited capabilities of the sandbox, right? I all the initiatives that I've done myself with doing .NET stuff, there was so much heavy lifting that the developer needs to do him or herself in order to achieve that. and it should be straightforward for a developer just to use technology in a secure manner, right? The secure defaults I prefer to I referred to before. So that's the thing I mostly look forward to if the tooling falls into place, and then if developers can work with it with an easy way. Also, the fact that I'm just curious if you look at it from a capabilities perspective right now. With Fermion, it's the cloud stuff. You right now the thing that you limit is mostly the component definition that you have right now, right? If you would compose a component model together, I would say that that's the moment where you also define security policies and what stuff is allowed to do or not. If you have like a composite app, right, compared to a module that gets run like a workload that's on the cloud thing, right? A serverless workload that will just fire and that will just do its stuff and then gets back to you, right? That's different than having a composite app where you want to have that granular control. And hopefully a developer can tell you like, hey, I would expect it not to reach out to an HTTP stack because there's no need to do that. And if that's running in a server-side context, then if somebody can do an HTTP request and control that data that ends into that request, you can end up in a problem like request forgeries. There you can harvest data of systems, right? Those are all the big issues. And I think that's the thing I mostly look forward to, like the whole being able just to do that polyglot thing and put your security in declaratively and have it work, right? I think that's the thing.
So you're saying even more fine-grained and even more capabilities based? Would you?
I think it should be a possible way of doing, but I also would like to see some good defaults that everybody could just start using, right? The example I always use within .NET, because I'm a .NET guy, if you want to suppress certificate validations, there is I think it's almost like it has dangers in its name if you do that call. And that makes sense because then people hopefully think about doing it before they really do it, right? Is it really needed? I think that's the key thing. We need to have defaults. I also need to have the control if people need to have it, like that they can grab it if needed, right? And that's probably needs to land. And I think that's the big plus what I see with the component model. If people start using it and give feedback, then hopefully everybody who's involved can see what works best and doing it right for developers. I think that's the key thing we should focus on. And then this can be a success for all the things that we talked about.
Awesome. Yeah. I look forward to it. And honestly, I wish I even knew what some of the updates in the .NET 9 release would be.
Same here.
Yeah. But as soon as I do, you can be sure we'll talk about it here on the stream.
That sounds really good. For sure.
Yeah. Sounds good. Anything else you want to demo for us?
I think I'm good. I'm curious because the slides are in PDF right now where I'm going to end up. I think this is my conclusion, right? And almost like explains what we talked about, cloud native, big milestone. And this is the repo. The first dot is the repo where the demos can be found, where I also have some of the other stuff with the markdown files that will explain the demos itself. And if people want to talk to me, these are the things you can reach out to me. So if there's no question, then this is all I have right now.
Yes, I'm going to put it in the chat so that people can access it. Yeah, here's the repo, folks. It's github.com/Niels Tanis/FermionStream 2024. His GitHub has a bunch of other things. And Niels, you're doing a bunch of talks coming up as well, right? I think NDC and a few others in case anyone.
Yeah, I'm also I've got a couple of local ones, NDC ones for sure, and also the WASM OPSEC ones, which are like more security developer focused events, which I think is quite cool. I still enjoy mostly talking to the developer audience because looking at security, it's easy to grab a brick and to break a window, but you need to build it in a safe way, and building stuff it's much harder. And that's the thing I like. But yeah, I'm definitely on the road for the next couple of months. My wife was already complaining that might be too much, right? So then I need to pay attention to that as well.
Yeah, same. Conference season has just begun. So I'll be speaking at Dev World in Amsterdam on Friday. I'm at Open Source Day in Italy next week, and I'll be at KubeCon with the rest of the Fermion team in a
Nice.
few weeks. So yeah, conference season is in full swing. If anyone is at any of these conferences that either Niels or myself mentioned, please come by and say hi. We always love to meet folks and developers, especially in person. So that'll be fun.
Okay. Thanks.
All right.
Thanks for having me. I
Yeah.
enjoyed it.
Thanks again, Niels. And yeah, we'll probably have you sometime again to talk about the WASI preview stuff, the .NET 9 stuff, and do another deep dive.
That would be cool. Let's do that. Cool.
All right.
Thanks.
Okay. Thanks everyone for joining in. Next week we have a stream with Ben from Leptos. We did a deep dive with the Leptos spin stuff earlier. Leptos has a bunch of new things coming up, and Ben has also done some pretty cool stuff with Tree Sitter, and I think he's just pushed that to like a repo out there. So that's some of the stuff we'll be speaking about. So join us next week as well. From Niels and myself, thank you so much for joining in, and we'll see you next week. Bye.
Yeah, thank you. Have a nice evening, everyone. Bye.